Financial Modeling, Topic 7, Static and Stochastic Multi-Period Portfolio Modeling for Financial Planning using Excel, Macros, and the at-risk software, including an analysis of 4 common rules of thumb in financial planning. Those rules of thumb are save 10% of your income for retirement. Number 2, your portfolio will double by the rule of 72. 3, allocate 120 minus your age in stocks. And 4, in retirement, you can safely withdraw 4% of your portfolio annually. One reference in Financial Modeling, 4th edition by Simon Benenga, is Chapter 1, Basic Financial Calculations. Section 1, construct a multi-period portfolio model with contributions and withdrawals and using Excel financial functions and also the rule of 72. In future topics, 2, 3, 4, and 5, we'll be doing multi-period stochastic modeling. So let's look at the first question. How much money will you have in 40 years if you start with $5,000 today in your account? You contribute $10,000 per year for 40 years, for 40 payments, and you earn 5% per year. So we can go to our spreadsheet. And we have the inputs. $5,000 is my portfolio balance today. My contribution is $10,000. I'm going to make that contribution at year end, so 1 year from today. The expected return on that portfolio is 5%, and I'm going to make 40 total payments. Now I first will start off down here and say my portfolio will start off at $5,000. That $5,000 will then grow at my expected return. I'll anchor the expected return. And then since this is year-end contributions, I'll then add my $10,000 contribution. So at the end of the first year, I have my $5,000, which that's going to earn 5% or $250, and then I'll add a $10,000 contribution. I'll copy this down, and you can see 40 years from today, you'll have $1,243, $1,243,198. Now, I didn't actually have to do this because I could have used the future value function and said 5%, 40 years, negative $10,000 payment. Now I'm making a negative here because in the financial functions in Excel, it's helpful to think of inflows and outflows. In other words, if I have an outflow of $10,000 today, annually, that's under payment, and at a present value, if I also deposit $5,000 in an account. So these are 2 outflows. I'll leave the type blank. Type means end of year payment. So this $10,000 payment doesn't happen until 1 year from today. And you can see it returns a value of $1,243,198. So I just wanted to test that by looking at doing this portfolio simulation or portfolio model over here. Another question you can ask in portfolio models is how much can you withdraw annually each year starting today if you have saved the $1 million from the prior question and you earn 5% in that account. So go back to the spreadsheet and you can see I've used a payment function. And that payment function says if you earn 5% for 25 years and put $1.2 million, that's from the prior question, in an account, and at the end of the 25 years you have nothing left, and that first payment starts today, which is a value of 1 for beginning of year payments. If you leave it blank or put a 0, it's end of year payments. So in this case, I'm withdrawing. How much can I withdraw starting today for 25 withdrawals and have just enough money? And that turns out to be $84,008. So that tells me that I can take $1.243 million at 5% for 25 years starting today and withdraw $88,000 a year, or $84,008 per year. And I can try to prove that right now. if I have $1.2 million in an account, and that balance earns 5%. However, before I even earn the 5% on this, I'm going to first withdraw my first payment of $84,000 to myself. So if I start off with 1.2 million, I then pay myself immediately today $84,000, anchor that, and then that balance earns 5% interest or return. At the end of that year, first year, I'll have $1.217 million. I'm going to copy this down, and what you'll notice is exactly 25 years from today is exactly a zero balance. So that's what this payment function is telling me. How much I can withdraw starting today, that's what the 1 is, if I have the 1.24 million in the bank for 25 years at 5%. I'd like to take a little time just to go over the most common 5 financial functions for financial planning. That is the present value function, the payment function, the future value function, the end period function, and the rate function. The present value function does exactly what it tells you. It tells you the value today of some future set of cash flows. Those cash flows can either be one future value amount or a series of payments. So the parameters for this function is the interest rate or rate of return, the number of periods, the periodic payment, and optional is future value amount, and optional is beginning or end of year payments. So I'm going to try to answer the question, how much will you need at retirement if you would like a $100,000 25-year annuity starting immediately, plus $10,000 left over for a funeral, presumably, if you earn 5%. So we're going to kind of fast forward to your retirement age. And if you're at retirement and you're forecasting you're going to live for another 25 years and you'd like $100,000 a year for those 25 years starting immediately, and at the end of the 25th year, I also want to hand over $10,000 for my funeral, how much money will I need in present value terms at retirement? I'm going back to my spreadsheet. And how I'm going to answer that is with my present value function. And what I'm going to say is the rate is 5%, 25 years. I'm going to withdraw a $100,000 payment starting today and a payment of $10,000 future value at year 25 years from today. And that tells me that that present value of those cash flows is $1.48 million. So in other words, if I put $1.48 million in an account today, I should be able to replicate those cash flows. One way of thinking about how that number is calculated is I put in my $100,000 today, and then the present value of my $100,000 for the next 25 years, and I sum all that up and include that $10,000 burial expense or funeral. That exactly equals $1.48 million. So you no longer have to do portfolio modeling like this. You can just decide or use the PV function. The next function, the payment function. The payment function tells you what payment you could create given future values and present values and periods and rates. So say you need $1.48 million from the previous problem, right? This problem told me that at retirement, I will need $1.48 million to replicate this $100,000 25-year annuity. So now you're back to today. All right, I know 40 years from now, I need $1.48 million. How much do I need to start saving or contributing to a savings plan starting today that earns 7%? Back to the spreadsheet. I'm going to use the payment function. And what I input is that I have a 7% for 40 years until retirement. I have no money today, and I want a future value of $1.48 million 25 years from today, and I want to start contributing payments today. That's a 1 and not a 0. How much do I need to put in the account? And that's $6,941.71. And then I just proved it here. if I put $6,941 in an account today, and then that $6,000 grows at 7%, and then I add another $6,941, and I keep continuing that process, I will have exactly $1.482 million at the end of the period. Notice in year 39, that's the last payment. Because payments started at period 0, that's a total of 40 payments going from 0 to 39. So that last year is just growing at 7%, and that gives me exactly the $1.482 million that from the prior problem. Next problem. This problem says I need to save $6,900 a year. What if you can only contribute $6,000 for 40 years? You earn 7%. How much will I have? Well, go back to the spreadsheet. If I can only contribute $6,000 as a payment starting today, I have no money saved already for 40 years at 7%. This FV function, future value, tells me how much money I will have. I will only have $1.28 million, not $1.48 million if I contributed the higher amount. So that's the FV function. The N period function tells you number of periods given the other parameters, rate, and so on. So if I go to my number of periods problem, if you only save the $1.28 million from the prior problem, how many years will the money last if you earn 5% and you begin to withdraw $100,000 per year starting today? So in other words, I now only have $1.28 million. I still want to withdraw my $100,000 a year at 5%. How many years will it last? And if I go to my function, I type in 5%, $100,000 is a negative. Present value, $1.2 million. 0 is my future value, and 1 is the type, and that gives me 19.3 years. I could prove that by saying, okay, I start off with $1.281 million. I start withdrawing $100,000 a year. And between 19th and 20th year, I run out of money. Next problem. The NPER function and the rule of 72. The rule of 72 tells you how long it takes for your money to double. However, that depends on the interest rate, right? The higher the interest rate, the faster your money doubles. Now I could do an N per function, and I do that down here. That I could say, if the rate is 1%, and I have $1 present value in an account, that's an outflow, and I get $2 as a future value, how many periods does it take? And you can see it takes 69 years. However, if I'm earning 6%, it only takes 12 years, or 11.9 years. Now the rule of 72 is an approximation. If you take the number 72 divided by the interest rate as a whole number, in other words 72 divided by 6, that number is equal to 12, and what you can see is the rule of 72 does pretty well. At 6%, it takes about 12 years to double your money. If we think the expected return of the S&P 500 is about 7.5 or 8%, it's going to take between, say, 9 and 10 years to double your money in the stock market, assuming normal returns. The last function is the rate function. The rate function will simply tell you what rate of return do you earn given present values, future values, payments, and etc. So what rate of return do you need to earn if you have $100,000 today, if you contribute $10,000 annually starting today, and want to have $1 million in 20 years? So back to my functions. I've done the rate function, and I've said 20 years. I put in $10,000 a year starting today, I also have $100,000 I placed in the bank today. That's my starting position. How long will it take to get, what rate of return will I need for 20 years to get $1 million? And that number is 8.27%. So I start off $100,000 in my account. I add $10,000 a year, and magically it takes me exactly 20 years to get exactly $1 million at that interest rate of 8.27%. So in this topic, we constructed a multi-period portfolio model with contributions and withdrawals and using Excel functions, and we discussed the rule of 72.